Math class, and in this live class we want to look at the topic matrices in mathematics. Then what is a matrix? A matrix is a rectangular array of quantity, usually in numbers, that is arranged in a rectangular array and enclosed within a large bracket. So for instance, we have something like 1, 2, then 0, 3 here. This number here enclosed within this bracket is what is called a matrix. Then we have something very important to note in matrix. There's something we call row. Then the number on the horizontal line like this is reversed to as the row, and here this is row 1. Then we have 0 and 3 here as the number in row 2. Then also we have column, that is vertically arranged number is reversed as column. So here we have column 1, and here we have column 2. Then that makes us to go to what is referred to as order of a matrix. The order of a matrix is usually given in terms of row, comma, column. So there is a way that a matrix is usually arranged. That is the order of a matrix, which is very important. Just like we have in Cartesian plane, there is something called ordered pair. That is, in Cartesian plane, the order pair arrangement is usually in form of x, y. Then in matrix as well, there is an order of matrix, and this is usually in row first, then column second. So we have row, column for a matrix. Then it implies that this matrix here now has 2 rows and 2 columns. So the order of this matrix here is said to be of 2 by 2. That is, here we have 2 rows and 2 columns, which is a square matrix there. For instance, let's give another example here. We have 1, 2, minus 3. Then we have 4, 5, minus 2, enclosed in a bracket. Here we have a matrix whereby we have 2 rows here. So we have 2 rows and we have 3 columns. So the order of this matrix here is going to be 2 by 3. So we have 2 by 3 matrix here. That is, we have 2 rows, then 3 columns. That's the order of this matrix, and so on and so forth. And also we might have something like this. We have 1, 0, minus 1, 2, 3, minus 2, then 0, 1, minus 3. Now, here in this matrix, we have 3 rows. That is 1, 2, 3. Then we have 3 columns. That's 1, 2, 3. That is, here we have a 3 by 3 matrix from here. So that's order of a matrix. We should understand that row is coming first, then column second. That is how we arrange matrix. Then it's important to note that here the element here is refers to, let's write it out properly. And this one we have, in general, we refers to this first number here as the element in row 1, then column 1. So 1 here is element in row 1, column 1. That is, in general, we can say this is equivalent to A11, then A12, A13, then here we have A21, A22, then A23. Now, what this one means is that the first number here is signifying the row in which this number is, and the second number here signifying the column. Now, the first one here means that we have this number in row 1, column 1. And what this one means, the second one here, it implies we have this number in row 1, then on column 2. Then here we have this number in row 1, then on column 3. Then also in the same way, we have this here in row 2. So the first one is row, as we have it in order of a matrix. So we have element in row 2 here, column 1, the element in row 2, column 2, element in row 2, column 3. Now, for instance, here, the element in row 2, column 1 here is 4. So I can say A21 in this case equals to 4. Then I can say A23, element in row 2, column 3, A23 here is minus 2. That's row 2, then column 3. So that's order of a matrix there. And then how to identify the element in the corresponding position. Now, for instance, let's look at these two matrix given here. And we write out this element from there. We have the first matrix denoted as matrix A, which is equals to, we have 1, 0, minus 2, 3, then 4, minus 5. Then we have another matrix denoted as B, and this here we have it as 5, minus 3, minus 4, and 2. So we have matrix B here. Then now let's identify the following. So determine number 1. Determine the following. Determine question here now. The order of matrix A and B, the order of A and B. Then 2, determine the, that's B, 1, element in row 1, column 2, that's A12. Then also we have A22. Then 3, we have A32. Then 4, we have B11. Then 5, we have B41. So we have to determine the following now. From what we have here, the order of matrix A and B. The order of matrix A here, as we have it, that order of a matrix is usually in row, comma, column. That is, we always have row and column. That's the order of a matrix. Now, the order of this matrix here, for A, we have 3 rows, 1, 2, 3. So that means solution from here, the first one, which is A, order of matrix A here will be equals to 3 by 2, because we have 3 rows. We have 3 rows, 1, 2, 3, then we have 2 columns. So order of matrix A equals to 3 by 2 matrix. Then for B, order of matrix B, this is equals to, here we have 1, 2, 3, 4. We have 4 rows here in this matrix B, and we only have a column. So that means here, we have the order should be 4 by 1. That's 4 rows and 1 column. Now, the second question here, which is question B, we have to find the first one, A12. A12 here means element in row 1 and column 2. The first number here is signifying row, and the second number here is column. So element in row 1, column 2. Then row 1, column 2, it means we have this as 0. So A12 here equals to 0. Then the second one here, which is A22, that is element in row 2, column 2. Element in row 2, column 2 here. So the element in row 3, column 2, this is row 3, then column 2. That's minus 1 from here. That is excuse me, please. The next question there, which is number 4, from our figure 4, we have B11. That means here we are dealing with the matrix B now. So B11 means the element in row 1, column 1. This is row 1, column 1. It's only having one column. So row 1. That means we have 5 here as B11. Then the fifth one also, we have B41. And B41 here, element in row 4, column 1. So this is row 4. And that element there is 2. So that is that. That's the solution to this particular question. So we are able to identify the order of a matrix and also to identify the element in each of the position of a given matrix. Now let's look at the types of matrix. In this class, the types of matrix. Next, we have some types of matrix, and we go through it in this class. The first one here, we have a row matrix. A row matrix. Let me quickly show this. So types of matrices. Type of matrices. So the first one we have, number 1, a row matrix. A row matrix. Now, for a row matrix, just as the name implies, it has just only one row. So this type of matrix has only one row. Though it might have several other columns, but has just only one row. For instance, let's have a matrix A here, which is equals to 1, 4, 6. We discover that this matrix has just one row, but has 3 columns. So it means here the order of this matrix is 1, by 3. That's 1 row, then 3 columns. So this is just a row matrix. It's just a row matrix. Now, the next type of matrix is a column. A column matrix. And in this type of matrix, we have just only one column. Only one column. But might have, several rows. So, for instance, e.g., we have this matrix. Let's say we have 2, 5, 6 here. This is having just one column, but has 3 rows. So this order of a matrix now is 3 by 1. That's the row first, then the column. That's 3 rows, just one column. So only one column here. That's a column matrix. Then we also have the next one, 0 or null matrix. 0 or a null matrix. As the name implies, this has all the elements to be 0. So all the elements are all 0 in this type of matrix. All elements are zeros. So it might be any type of matrix like order. For instance, we have 0, 0, 0, 0. So here, all the elements here are 0. So this is a null matrix example here. Now, we have the next one, number 4, is square matrix. A square matrix. And for this type of matrix, just as the name implies, it has equal number of row and column. That is, the number of row is same as the number of column. Equal number of row and column. So that's a square matrix. For instance, we have this matrix 1, 3, minus 2, 7. So here, this matrix is a square matrix because it has 2 rows and 2 columns. So we call this 2 by 2 matrix. Or we might have also 3 by 3. We have 1, 0, 4, 4, 3, 6, then 8, 7, 2. So here as well, we have equal number of row and column. That is, we have 3 rows here, and we also have 3 columns. So this is 3 by 3 matrix. So these two types of matrix are called square matrix. Then we have another one too, a diagonal matrix. A diagonal matrix, that's the 5th one. A diagonal matrix. Now this type of matrix has the elements only on the diagonal. That is, all other elements are 0 except the one at the diagonal, at the leading diagonal. Now, for instance, e.g., we have this matrix 2, 0, 0, and we have 0, 1, 0, then we have 0, 0, minus 4. Now, here, this matrix is a diagonal matrix because the only number we have is the number in the leading diagonal. So all other numbers there are all zeros. So we call this type of matrix a diagonal matrix. Now, we also have another type of matrix. We call it a unit matrix. For a unit matrix, number 6, we have unit matrix. For unit matrix, it follows from a diagonal matrix. But in that case, the leading diagonal there has just unit, that is 1 on the diagonal. For instance, we have 1, 0, then 0, 1. So this is a unit matrix, also a diagonal matrix, but as just a unit, that is 1 on the leading diagonal. I might be 3 by 3, that is we have 1, 0, 0, 0, 1, 0, 0, 0, 1. So here also we have a unit matrix. The leading diagonal here are all 1. So that's a unit matrix. And lastly, we have what is called equal matrix. And equal matrix, when two matrices are equal, their corresponding elements are equal. For instance, here, okay, let me write it here. We have the number 7 equal matrix or equal matrices. So when two matrices are equal, for instance, we have A, B, C, D. If this is equal to another, matrix, say we have 4, 3, then 2 minus 1. If this is equal here, it implies that the corresponding elements are equal. That is, A is equals to 4, and B is equals to 3, C is equals to 2, D is equals to minus 1. So those are equal. So we have these 7 types of matrices here. Then, next thing here, let's look at matrix algebra. That is addition and subtraction of matrices. First, in this class, addition and subtraction of a matrix. So here we have matrix algebra. We can add and subtract two matrices, 2 or more matrices. Now from here, generally, if we have a matrix A given by A11, A12, A21, A22, here we have a 2 by 2 matrix, and we have a matrix B given by B11, B12, B21, B22. Also here we have a 2 by 2 matrix. Now, then addition here, which is A plus B, will simply be equals to addition of the corresponding elements. That is, we are going to have A11 plus B11, then we have A12 plus B12, then we have A21 plus B21, then we have A22 plus B22. So we only had the corresponding elements there together. Then the same way for subtraction as well. And also A minus B will be equals to A11 minus B11, then A12 minus B12, then we have A21 minus B21, then also we have A22 minus B22. So this is the general form. Now let's look at some example there. Excuse me, please. That is, here, let's consider these two matrices. Example. So let matrix A be equals to, we have 2 minus 4, 3, 2 minus 4, 3, and we have 5, 1, 0. Then also we have matrix B, and that's given us 1, 4 minus 2. Then also second row we have minus 3, 3, then minus 1. Find the first one. What you are finding, number 1, A plus B. Then 2, you find A minus B. Then 3, you find B minus A. Now, solution from here, since what we have here, we just add the corresponding element. That implies that A plus B here, the first question, will then be equals to the corresponding element here, that's 2 plus 1. Then also we have minus 4 plus 4. Then we have 3 plus minus 2. 3 plus minus 2. Then also we have 5 plus minus 3. 5 plus minus 3. Then we have 1 plus 3. Then we have 0 plus minus 1. Then this will be equals to what this one becomes. Here, we just add 2 plus 1, that's 3. Then minus 4 plus 4, that's 0. Then 3 plus minus 2, same thing as 3 minus 2. Plus times minus here, that's minus. So this gave us 3 minus 2, which is 1. Then here, same thing, plus minus here become minus. So 5 minus 3, that's 2. Then 1 plus 3, that's 4. Then 0 minus 1, that's still minus 1. So here we have the answer to the first one, which is A plus B. Then in the same way, to find A minus B, we subtract the corresponding element, that is here, the second question, A minus B will then be equals to, the first one to take is A. So we have A here, that's 2, then minus 1, that's 2 minus 1. Then we have minus 4, that's minus 4 minus 4. Then we have 3 minus minus 2. So we have 3 minus minus 2. The next line, we have 5 minus minus 3. That's 5 minus minus 3. Then we have 1 minus 3. Then we have 0 minus minus 1. 0 minus minus 1 here. Then when we simplify now, this gives us 2 minus 1 here, that's 1. So this becomes 1. Then minus 4 minus 4, we have minus 8. Then 3 minus minus 2. Minus times minus turn to plus. That's 3 plus 2, which is 5. Then 5 minus minus 3, that's 5 plus 3, which is 8. Then 1 minus 3, here we have minus 2. Then 0 minus minus 1, that's 0 plus 1, which is 1. So here we have A minus B here. Then also we have to find B minus A. That's number 3. That this B minus A here implies B is coming first. So we have to take B first here. That's 1 minus 2. Subtracting the corresponding elements. So here we have 1 minus 2. That's the first one. Then we have 4 minus minus 4. That's 4 minus minus 4. Then we have minus 2 minus 3. The next line we have minus 3 minus 5. Then also we have 3 minus 1. Then we have minus 1 minus 0. Then when we solve this, this becomes, here, 1 minus 2 here give us minus 1. Then 4 minus minus 4, that's 4 plus 4, which is 8. Then minus 2 minus 3, minus 5. Then here we have minus 3 minus 5, minus 8. Then 3 minus 1, that's 2. Then we have minus 1 minus 0, that's still minus 1. So here we have B minus A. So that is addition and subtraction of matrix of matrices. And you have been watching us at Master T Math class, and thank you for joining us in this class. So do well to subscribe to this channel for more of our videos. We appreciate you, and then thank you. See you in our next class, and bye for now.